Hey guys, welcome. Today I'll be teaching you guys about perspective projection. This is the second part of camera calibration. In the first part, I taught you about the linear camera model, and now we will move on to perspective projection. What we do in perspective projection is we find the coordinates of the image on the image plane when the camera coordinate is given. So we basically know the position of the object with respect to the camera coordinate frame, and now we want the position of image in the image plane. Alright, so we want xi when we know xz. So to find it, we will simply use this triangle and this triangle, and we will use this triangle basically. So we will be using similarity of triangles. So how we can use similarity is this would be the focal length and this is ZC. So we will simply apply similarity of triangles, and it will be YI by F is equal to YC by ZC, and XI by F XC by ZC is what is given here. So with this we will know the position of XI and YI. So now what it is given is that all focal length, position, Y position, Z position, all of this, and also ZC, XC, they are all in millimeters. But what we want from XI and YI is that they are in pixels, because in an image we measure the distance in pixels. We will be defining another metric known as pixel density. What pixel density basically is, it's just how many pixels are there per millimeter. Now what we have is millimeter, because all the units, they are all the focal length YC, ZC, XC, they are all millimeter. We can define one pixel density, and with this we can get the unit in pixel. So what we have to do is just multiply the x coordinate in millimeter to a pixel density that we are defining in the x direction. So we have u, that is x coordinate in pixels, equals to mx by xi. In similar way we will have v, that is my by yi. Alright, so the coordinates of the image in the image plane is now u and v, that is based just the above equation multiplied by their pixel densities. So this is just mx into xi comma my into yi. So after finding the x and y in pixels, we are facing yet another issue, that all the calculations of the image plane are being done by taking the point where the optical axis passes through the image plane to be the origin. But in real life we always take the top left corner to be our origin. Right now we are taking this as our origin. Now we want to shift the origin here, and let's assume this point is ox comma oy after shifting the location of the origin. So each pixel point in this image plane will be also shifted by ox plus oy. Basically u will become u plus ox, v will become v plus oy. This is simple shifting of origin. So this is our new equation, and we assume that mx into f is equal to fx and my into f is equal to fy. In this equation, this fx, fy, ox and oy, all four of these are depending on the cameras only. We as a user, we can place the camera anywhere in the world. These four things will not change. These come with the manufacturing itself. So this is called as intrinsic parameters of the camera. This is all internal to the camera. In the equation of u and v, zc is in the denominator. Because of this division, this u and v are not currently linear, and to make this whole equation linear, we will use homogeneous coordinates. I'll teach you about homogeneous coordinates in the next lectures. So thank you so much.